Okay, so we're going to look at 8.3 and 8.4 today. Let me grab my various colors, which I'm losing colors rapidly. Okay, so a couple things. An inverse matrix, everybody needs to focus. Everybody needs to focus. Here's how an inverse matrix is created. So let's say that I have AX equals B for Chuckle's sake. How would you solve for X? Divide by A, right? I'm going to scroll into this. And so wouldn't X equal, if I divided by A, X would equal B over A, right? But we don't actually divide by, let's just assume that A and B are matrices. We don't actually divide matrices. We can multiply them, we can add them, we can subtract them. We don't actually divide. Another way to describe A would be X equals A to the negative 1 times B, wouldn't it? In other words, isn't 1 over A equal to A to the negative 1? Right? Remember that? So this is called our, this is what we're going to do with our inverse matrix. So write yourself a note. Since we don't divide, we use the inverse, and with matrices are really capital letters, to solve. Okay? So that's where the inverse matrix comes about, and I'll show you how to find it. So the very first thing in finding the inverse is we need to know what the determinant is. Do you remember how to find the determinant? Yeah, so this diagonal right here, A times D, is where that comes from. And then this diagonal here, I'll do that in pink, is where that comes from. So remember, this is your main diagonal. The main diagonal starts with the upper left and goes down to the lower right. So you always have to start with the upper left. And I'm only going to make you do a determinant by hand with a 2 by 2. The minute we get to the 3 by 3s, I'm going to show you how to do it on the calculator. So just bear in mind that all 2 by 2s you must do by hand, all 3 by 3s on your calculator. Fair enough? Okay. So we're going to use that determinant to find our inverse. So here's how the inverse is determined. To get the inverse, you're going to take 1 divided by the determinant, and this is going to be an actual number, okay? And then so this becomes a scalar. And then look at the difference between the original matrix and the new matrix. What happened on the main diagonal? Yeah, so on the main diagonal, the only thing that happened is these elements switched places. Right. This is the way it works. If you want to know why, remember, if you want to know why, I'm going to have to tell you. You don't want that. There's a why to it, but you really don't want to delve into it right now, do you?
No, I'm just wondering what the disappointment.
I'll show you why in a minute. We are finding the inverse of A. What does a matrix have to be in order to use it for division? So remember, if we don't divide by matrices, we have to have a way to do division.
Yeah.
And so we have to have a way to find the inverse of A, which is 1 over A. Right? That's how we end up dividing. And so this is one of the things that we do. Then look at this diagonal. What's happened here based upon the original They're in the same place, aren't they? Well, what happened? They, well, not necessarily negative, they change signs, right? Because what if b is already negative? Then if I multiply it by negative, it's going to become a positive, right? So these elements stayed in the same place but change signs. So we're going to practice finding the determinant, or not just the determinant, the inverse on these two matrices below, and then I'll show you how to do it on your calculator when it's easy, and then we'll do it on the 3x3s. So here we go. And not all matrices have an inverse, by the way. You'll see what happens if it doesn't, and your calculator will tell you if it does, and I'll show you what that looks like as well. So we're going to have two different steps. Step one, you're going to find the determinant. So to find the determinant, I'm going to actually take my main diagonal, which is right here. I'm going to take 1 times 4, and I will subtract, always subtract from that the second diagonal here, 3 times 2. So I end up with 4 minus 6, which is what? -2. So there's my determinant. Then I have to find the inverse. So step 2, find a to the -1. So I'm going to have to back out of this a little bit so you can see all my work. So follow the formula above. A to the -1 is equal to 1 over our determinant was -2, right? Then times our new matrix. And so remember, the main diagonal, they switch places. They do not change signs, they just switch places. And then on the secondary diagonal, they stay in the same place, but they change signs. So these two end up becoming negative, only because they were both positive. Then what are we going to do? Yeah, divide everything by -2, which means everything is going to change signs, and if 2 doesn't go in there, you will write it as a fraction. So we end up with 4 divided by -2 is -2. -2 divided by -2 is +1. -3 divided by -2 is a fraction, +3/2. And 1 divided by -2 is -1/2. So this is your final answer. So there is a determinant. There is an inverse for this one. Then I'm going to give you the directions on how to find it on your calculator. So you ready? Let's blow the directions up a smidge. So on calc, that's on your calculator, not your calc menu. Input matrix A, and we talked about how to do that yesterday. To input matrix A using the matrix menu. Then on the main screen, you have to get out of the matrix menu. Select matrix A. Next step, press X to the -1 key, then enter. Now, if your matrix ends up with decimals in there, then you have to hit the math, enter, in order to get your fractions. So let's go ahead and do that on our handy dandy calculator. As soon as you're done writing that down. Anybody need more time? Because I'm going to take the instructions away. Well, I guess I'm not. I'm just going to show you my calculator. All right, so I'm going to go into, and you know, it's possible because this is the same matrix I think we used yesterday that it might still be in there. So second function, x to the negative 1 key gets you into your, on my calculator, gets you into your matrix menu. And then I'm going to go over to edit, and I'm going to, my 1 is highlighted, so that means I'm going to change my matrix A, if it's not already 2 by 2, which mine is, make it 2 by 2, and then make sure you have 1, 2, 3, 4, because this is what we used yesterday, isn't it the same? Right? So I can X out of this, so I'm back to my main screen. So if I want to find my inverse, I'm going to select matrix A, so go back to your matrix menu. Oops, that was not, I did that yesterday. Go back to your matrix menu, because I can't see. And then I just want to select A right there. But I want that to be A to the negative 1. So can't I then press my X to the negative 1 key right here? So that's A to the negative 1, and then press Enter. What do you notice about my matrix? That decimal. So I don't want the decimals in there. So I'm going to go to my Math button, and I'm going to enter because I want fractions. And then, so it's saying answer fractions, hit enter again, and now it rewrites the matrix but with the proper fractions. Is that what we got by hand? So you can check your answers via your calculator, so long as your 2 by 2s in your homework, you're showing the work. Question? How I got the fraction? I went to, so when I did my matrix, this is what I had, right? So then you go to this math button right here. So click on math. Do you see how fractions is highlighted? Right here. Then you want to just hit enter. Now it's saying take the answer above and write it in fractions. That's what you're telling the calculator. Hit enter again. And then it should give you the fractions. Did it work? Yes. Because your calculator does that. It's just older. He wants to know why. He's got parentheses around his matrix. It's just because it's an older calculator. No, you don't have to write don't write the parentheses. Huh? Yours is the same thing. All right, so then let's go ahead and do B. And let's do B by hand. So you go ahead and try that on your own. See if it has an inverse. I'll show you one that doesn't. Well, if your determinant comes out to be 0, are you going to be able to multiply anything by 1 over 0? That's really what's going to happen. That's how you'll know. And you won't know it if you put it into your calculator like we just did, but your calculator will give you a syntax error. So that's how you'll know on your calc. And then I'll also show you how to find the determinant. Well, let's look at the determinant. Before you do this one, I want to show you how you can find the determinant on your calculator also. So we found the determinant for this one to be -2, correct? So go to your matrix menu. Okay, so I'm in my matrix menu and scroll over to math. What do you see highlighted here first? What do you think that means? Determinant. So I'm going to press enter, and it wants to know the determinant of what? The determinant of what matrix. So then you go back into your matrix menu and tell it what matrix you want it to find the determinant of. I want it to find the determinant of A. I like to end my parentheses. It won't make a difference. And then I hit enter, and look what it gave me, -2. So if that determinant comes out to be 0, that's when you won't have an inverse. Okay, so you do this on your own, and I'll do it quietly by myself. Bless you. everybody sneezes, just like everybody toots. Nope. Oh yeah, there's people you know that don't toot.
Yeah.
I don't believe that a boy does never toot. And boys, contrary to popular belief, girls do toot. Just to let you know. Alright, so this one, because you just said sneezing was gross, I'm like, it's a bodily function. It happens. Alright, so 8 divided by -2 is -4. -7 divided by -2 is a fraction 7/2. -6 divided by -2 is +3. 5 divided by -2 is a fraction -5/2. So then I'm going to test it in my calculator, both my determinant and my inverse. So here's my handy dandy calculator. I'm going to try my inverse first. So second matrix, find my determinant. And I need to tell it that it's matrix B. So go back into your matrix menu, scroll down, or hit 2. Now it's matrix B. My determinant is also -2. Then find your inverse. So second matrix, I want to find the inverse of B. So I could either scroll down or hit 2. It gives me B. And then I want to hit my inverse, my x to the -1, right there, and hit enter. But I have decimals. I have decimals, go to your math button, and hit enter, enter. And now I have my fractions, and it agrees, right? And then one other thing that I want you to write down here, note to self, any matrix times its inverse will result in what's called an identity matrix, which we looked at yesterday, right? And remember that identity matrix for a 2x2 would be 1, 0, 0, 1. So we're going to prove it by taking either of these two matrices and multiplying it by its inverse. So as soon as you write that down, we're going to multiply these matrices by their inverses. I'm going to do it to both of them. Ready? All right, so here we go. Let's take matrix A. So second function, matrix. We're going to take matrix A, so enter, then hit the times key, and we're going to multiply it by its inverse. So second function, matrix A again, but I want that to be x to the -1. Then hit enter. Oh, looky there. It's magic. I love it. Then I'm going to do it to B just to prove to you it's not just a coinky-dink. So we're going to choose B times B again, but the inverse. There it is. It's magic. Yes. When, let me see what you put in. You might have to, let's see. Did you get that, Amber? Did you try it? Did you get an error? Maybe it's your matrix. Let's see.
I also did it separately.
You did what?
I did it separately.
Let me see.
I found the inverse first and then I timed it right.
No, you don't want to do that. Try what I did on your calculator. I want to see if you get the same answer as he does. You just, oh, you have 2, 2, 2, 2. Oops, that's why. And because the reason why, yeah, yours worked, right? The reason why yours didn't work is because your matrix was all full of 2s, and so your determinant was 0. Does that make sense? Okay. All right. So any other issues with that? Let's flip it. Now, why have matrices? Okay, matrices are a beautiful thing. I can tell you that when I took pre-calc, I had to do 3x3 and 3x4. I had to do actually bigger than this matrices by hand. And then I looked up online because I get tired of doing this by hand because you know how long they take, right? So then I looked online how to use my little TI calculator, and I'm like, hey, there's a little matrix button on here. I go, oh, it's a much quicker way. Oh, it saved me oodles of time, which you'll be thankful for. So oodles, it's a technical term. So we talked about this system of equations and how to write it as a matrix. Now, I did show you yesterday to write it as an augmented matrix, but today we're going to write it slightly differently. So we're going to take our first step, and we're going to write this as a matrix on its own right here, and then this as a matrix on its own right there. But we have to deal with the x, y's, and z's. So your very first step is to write a coefficient matrix. So we're just going to write a 3 by 3, 2, 3, 2, ignore all the x's and y's, 3, 3, 4. If there's a minus in here anywhere, of course that would be attached to your coefficient, right? We're just dealing with all positives on this one. And so 2, 2, and 1. Then we're going to multiply that by our variable matrix, I like to call it. And you want to put them in alphabetical order. So you do want your x's all to come first, and then your y's, and then your z's. Whichever one you chose to come first here, notice that they're all lined up. That's why I just suggest you do it alphabetically. So this one came first, we're going to put x up top, then came the y's, so then comes y, and then came the z's. Equals, and then write your answer matrix. So you have two column matrices, right? And we're going to call this matrix A times matrix X, not X for this, but matrix X because it's a variable, and so we like to use a variable X, equals, we'll call this one matrix B. Right, so then we learned how to solve for X. We don't want to write X as equal to B over A, but we want to write it as what? A to the negative 1 times B, right? Because we can find A to the negative 1 of this matrix. So we're saying this whole matrix here is equal to the inverse of this times that. I did teach you how to multiply those, but fortunately we're going to do it on our calculator. Yee, yippee, right? You should be jumping for joy. You have no idea. This would take pages. Well, a couple pages anyway. All right, so then you are to, step 2, you are to find, I'll do that in purple, find A to the negative 1 on your calculator. So that means that you have to put in, you have to change your matrix A. So I'm going to go to second matrix. And I'm going to go to edit. So I scrolled over to edit, and I'm going to highlight A. Well, I'm no longer putting in a 2 by 2. What am I putting in? A 3 by 3. So hit 3, enter, so that you have a 3 by 3 on your calculator. Is everybody there? Everybody was able to do that. All right, so then enter in your elements. So I've got, and it's going to go horizontally. 2, 3, 2, 3, 3, 2, 4, 1. Is everybody there? Then exit out of there, so second quit, so you're back at the main screen. Now you can select that matrix. So second matrix, select A, and then you want to hit your x to the negative 1 key and hit enter. What's the problem? We have decimals, so we want to hit math, enter, enter. And now we have lovely fractions. So we're going to record that here. Now I will slash my fractions on here only because it saves me room, but you know how I feel about slash fractions, right? I don't like slash fractions. Don't slash fractions, not a good habit. But I kind of need some room here. We'll get a little cramped. Well, you could. I wouldn't. And I haven't taught you how to find the determinant of a 3 by 3 anymore. You need to go back and look it up at why. We have a calculator. Let's use our technology, right? All right, so then, so now that we have our inverse, now we can go ahead and solve. So then step 3, you are going to solve for x equals a to the negative 1 times b on your calculator. That's very exciting. I put an exclamation point. Super duper excited. All right, so I'm going to clear this out. So what I want to do is I'm going to select matrix. Oh, have I put B in my calculator? I got to put B in there. So we're going to go set that up. So hit your matrix, go over to edit, and now select B. So 2 or scroll down. I need a what by what? 3 by 1. And then I'm putting in a 1, and a negative 2. Make sure you're using the negative and not the subtraction. Now I can go back out to my main screen. Now put in the inverse of matrix A. So select matrix A, enter, hit X to the negative 1 button. So there's your inverse matrix. And then times B, so hit your times, and then second matrix, select B, and hit enter. Here's the fabulous thing. You just solve for X, okay? So that means that X is equal to 0, negative 1, and 2. What that means is that this is X, this is Y, and this is Z, doesn't it? And when we solved a system of 3 equations with 3 unknowns, how did we write the answer? We wrote the solution as an ordered pair, right? So step 4, the solution is. For our note purposes, we will write that X is equal to 0, Y is equal to negative 1, and Z is equal to 2. So that means our final answer is 0, negative 1, 2, a triple ordered pair. That was pretty painless, wasn't it? This is the answer I really want. How did we get that answer? Because we knew those. You don't have to write that in your homework. Don't you wish you had that in Algebra 3-4?
Yes.